Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today, we are going to look at activation energy. The activation energy is defined as the minimum amount of energy required to initiate a chemical reaction. And the energy is used to break the bond in the reacting molecule so that the new bond can be formed in the product. So we'll need to be able to identify the activation energy in two types of graph. One is in an endothermic graph. The other one is an exothermic graph. Alright, now let us look at the endothermic graph. So for endothermic graph, the reactant will always be having a low energy compared to the product. So this is the enthalpy of the reactant, and the enthalpy of the product is slightly higher. Right? So this, from here to here, this is the activation energy. Alright? So let us revise on enthalpy change. From here to here is going to be a positive enthalpy change because that is a difference energy between the reactant and product. Well, activation energy is always from the lowest point of the energy from the reactant to the highest point of this curve. Alright, so this is the activation energy. Whereas for exothermic graph, the reactant is always having a high energy compared to the product. So this is the reactant and the product will have low energy. So right, the activation energy is always from the lowest point of the reactant, which is here, to the highest point of the curve. So therefore, this to this is the activation energy. And the difference enthalpy between the reactant with the product, this difference in energy or the difference in enthalpy is known as enthalpy change. So from here to here, we call it as an enthalpy change. Let us look at past year questions on November 02. Questions 1. A. Draw a diagram to show the Boltzman distributions of molecular energies. Label the axis. Now let us do it together. We have our y-axis and the x-axis. So the y-axis is the number of molecule. And the x-axis is energy. So this Boltzmann distributions curve is an asymmetrical distributions curve. So it will look like this, for example. Alright, you need to know a few concepts. The area under the curve represent the total number of molecules with energy. Alright, you need to know that majority of the molecules are having energy at this area. You can see that this area is so huge compared to the area over here. That means majority of the molecule is here, they are having energy around this range. Okay, so for questions 1b, comment the shape of the distributions curve. Well, you can say that not all the molecules have the same energy because as you can see, some of the molecules are here and those molecules are having low energy. Some of the molecules are here. This molecule, this part of particles are having extremely high energy and majority are having normal range of energy. So you can write not all molecules have the same energy. Okay, some are having high energy, some are having low energy. Alright, so for the question C1, explain the meaning of the term activation energy. Well, activation energy is the minimum amount of energy needed to initiate a reaction. Alright? So, next, questions number 2. Insert and label the activation energy in your diagram in A. Well, look, the activation energy will be placing over here. This is activation energy. Or we can write a symbol EA. Meaning to say that only those area under the graph that is shaded over here only those molecules that is having this energy can react. That means they can overcome the activation energy in order for the reactions to happen. Now let us look at these questions, which is from November 14 questions 23. Use the Boltzman distributions shown to explain why a catalyst increases the rate of this reaction. Well, just now we have thought about the catalyst is having an activation energy which is usually happens around the right hand side of the distribution curve. Let's say this is the original activation energy. But when the catalyst is added, the catalyst is able to lower down the activation energy. So the new activation energy, which is lower, will be here. Alright, now let us look at the area under the curve. So for the original activation energy, the area under the graph is this much. The area under the graph represents the number of the molecule with enough energy to overcome the activation energy. That means only this much of molecule are able to react. However, when the catalyst is added, the catalysts are able to lower down the activation energy. So when the activation energy is lower, look, the area under the graph will increase. So that means the number of molecule is having, this number of molecule which is at this area, they have high amount of energy to overcome the new activation energy. So they are able to react. More molecules are able to react. Hence, the rate of reaction increase. Alright, so we will write this answer. The catalysts are able to lower down the activation energy so that more molecule have energy more than or equals to the activation energy in order to react. So then you can talk about the frequency of effective collision increase and hence the rate of reaction increase.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.